everybody, this is Miss Bufford, and in this video we're going to talk about Bohr's atom. So your learning goals for this video are to be able to correctly diagram a Bohr model of an atom, and this is really only going to be useful for the first 18 elements on the periodic table. So Bohr proposed the following about the structure of atoms. He said that electrons orbit the nucleus in energy levels that have specific energies associated with them. And what this means is that in order for an electron to occupy an atom in a specific energy level, it just has to possess a certain amount of energy to be there. And he said that those electrons in an atom of a given element can only orbit the nucleus at certain energies or distances from the nucleus, and that these distances are going to be different for each element. And this is based on the number of protons that there are in the nucleus. The way that they interact with the electrons will pull them, closer to the nucleus in some elements and farther from the nucleus in other elements. But whatever element it is, it's going to have its electrons or its energy levels at unique distances or energies from the nucleus. And then Bohr proposed that electrons can gain or lose fixed amounts of energy, which allows them to transfer from one energy level to another energy level, and that these electrons cannot exist between energy levels. So they're either in one energy level or the next energy level, but they're never ever in between. So Bohr also described the numbers of electrons that could occupy each of these energy levels or shells. And so here's our nucleus, and we've got our first energy level, and n equals 1 is just a way of describing the energy level. It's the quantum number that indicates which energy level you're in. So n equals 1 is the first energy level, and this can hold up to 2 electrons, all right? And then n equals 2 can hold up to 8 electrons. And n equals 3 can hold up to 18 electrons. And n equals 4 can hold up to 32 electrons. And if we look at the periodic table, and you know that the numbers over off to the left-hand side, they represent, or the rows across the periodic table represent energy levels. And you'll notice there are 7 energy levels. And so energy levels beyond this 4th energy level can theoretically hold lots of electrons, but they're not always filled up all the way because we don't have elements that are large enough to add electrons beyond a certain point. And so n equals 5 can theoretically hold up to 50 electrons, but known elements only fill this energy level up to about 32 electrons. And energy level 6 can theoretically hold up to 72 electrons, but known elements only fill up 18 electrons in this energy level. And then n equals 7 can theoretically hold up to 98 electrons, but known elements will only fill up to 8 electrons in this shell. All right, so the purpose of this video, like we said, was to be able to diagram some Bohr models of atoms. And so we're going to start here with helium. And a neutral atom of helium contains 2 protons, 2 neutrons, and there's our nucleus, and then 2 electrons in its electron cloud. And we know that the first energy level can contain up to 2 electrons. So we're going to put our 2 electrons there, and there is our Bohr diagram for helium. All right, now let's try a bigger one. We've got oxygen, and a neutral atom of oxygen 16 is going to have 8 protons, 8 neutrons, there's our nucleus, and 8 electrons. And so we know that the first energy level can only hold up to 2 electrons, so I'm going to fill that up first. And the second energy level can hold up to 8 electrons, but I only have 6 electrons left. And so when I put these electrons in here, I'm going to do this in a very specific manner. I'm going to pretend like there's a box around this nucleus, and I'm going to start up here at the top. And it doesn't matter if you go counterclockwise or clockwise, but I'm going to put 1 electron on each side of that box, and then I'm going to start doubling them up. So here we go. There's my first one, 2, 3, 4, 5, 6. And I'm going to explain this and why we have to do this in a video later on. I just want to, while you guys are doing these Bohr models, I just want to get you used to putting electrons around an atom in a specific way so that we're already used to it when we start learning about the Lewis structures. All right, so now let's try chlorine. So a neutral atom of chlorine-35 has 17 protons and 18 neutrons in its nucleus, and it's got 17 electrons around that nucleus. So there's our first energy level. There are the 2 electrons that can fit in that first energy level. And I still have, 15 more electrons to describe the locations for, so I'm going to need a second energy level here. And I know I can fit up to 8 electrons in here. So here I go. 6, 7, 8. All right, now I have 10 electrons on here. Chlorine has 17, so I have 7 more electrons, so I'm going to need a third energy level. So 1, 2, 3, 4, 5, 6, 7. And so there is my Bohr diagram for chlorine. I've got all 17 electrons around the outside. So now what I'd like for you to do is make sure that you've got your periodic table from class while you're doing this, because you're going to need it to be able to figure out how many electrons a neutral atom of each of these elements will have. And I'd like you to go ahead and pause the video and try to draw out these Bohr diagrams by yourself, and then you can unpause it and we'll go over them together. Okay, so hopefully you had an opportunity to pause the video and try out these Bohr diagrams in your notes. So let's go ahead and take a look at what these would look like. So aluminum has 13 electrons, and so it's going to fill up the first 2 energy levels with the first 10 electrons, and then it's going to have 3 in that outer energy level. And argon has 18 electrons, and so it's going to fill up those first 10 electrons in the first 2 energy levels, and then it's going to require 8 electrons in that third energy level. And then fluorine has 9 electrons, and so it's going to fill up the first energy level with those first 2 electrons, and then it's going to have 7 more around in that second energy level. And lithium is a really tiny atom. It's only got 3 protons in its nucleus, so it will have 3 electrons. And we're going to fill up that first energy level, and then in that second energy level, we'll just have a single electron. So hopefully you did well and you were able to diagram these Bohr models. If you had any questions, please go ahead and write those in your notes and speak up in class, and I'll be happy to go over anything you have questions about in class. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.